Alright, so we're ready now to look at an example of this inversion algorithm, this method for finding the inverse of a square matrix. And basically it's just doing row reduction, back to essentially doing Gauss-Jordan elimination that we were doing earlier. And again, the idea that we found that connects the two, or that creates this algorithm, is the fact that we observe the same sequence of elementary row operations that transforms A into its reduced echelon form, which is the identity if it is indeed invertible. We'll also convert the identity matrix into its inverse, the inverse of the matrix. And so what we're going to do, I'm going to look at this example. I'm going to use the inversion algorithm to find the inverse of this matrix A. What we're going to do is we're going to adjoin, we're going to create a partition matrix, adjoin the identity A, adjoin the identity to the matrix A. So what I do here is I start with the matrix A, and just copy that in. And I put a little dashed line here myself just to indicate the other matrix I'm going to adjoin here, which is the identity matrix. So here I put in the identity matrix. So together these create a 3x6 matrix. So I'm looking at the whole matrix. The dividing line just gives me focus. I want to focus over here on the left as I'm doing the row operations. Okay. And so what we're going to do is we're going to transform matrix A, just do Gauss-Jordan, put this in reduced echelon form, which if it's invertible is going to be the identity matrix. If I do reduce echelon form, therefore, if you remember, any square matrix, the reduced echelon form is either the identity or has a row of zeros. So if at any point in the process I get a row of zeros, then I know the matrix A is not invertible. I would just stop, there's no sense in going on with the process because there is no inverse in that case. But if it is invertible, then we're going to get the identity as the reduced echelon form. So how do I do that? I need a 1 in the upper left corner. I have a 1 already. If there wasn't a 1 here, I can multiply right by the reciprocal to get a 1 there, that row. But now what do I want to get? I want to get zeros beneath this 1. I want to get zeros here and here. So what I need to do then is to add multiples of one row to another. To get rid of this 1, I'm going to take row 2 and I'm going to add -1 times row 1 and replace row 2 with that. And then I'm going to take row 3 and add -2 times row 1 and replace row 3 with that. So I'm going to do that operation. Okay, so and to do that, as we have before, I'm going to use the TI-83 in this case to do that. So I go to matrices, I go over to edit. I'm going to edit matrix A, and I need to make it now into a 3x6 matrix, right? So now I carefully enter in these numbers all the way across, including the identity portion there. And definitely worthwhile to double check, starting with this last column, 0, 0, 1, 0, 1, 0, 1, 0, 0, 2, 3, 0, 2, 3, 1, 1, 1, 2. So just double check, make sure you've got that written in correctly. So I can quit, second quit, and now I'm going to go to matrix and just select A and hit enter. I've stored this matrix into my answer. There's my matrix I'm starting with, right? Now I'm going to perform these row operations. So I go to matrix and go over to math, go all the way to the bottom. I'm going to add a multiple of one row to another, so that's that one. Again, you might want to review that that sheet that I referred you to previously that shows you the syntax for how things are done. So when I do this, what do I want to do? I want to first enter the multiplier. What's the multiplier? -1. So I do -1. And then the matrix. Where's the matrix? Well, I'm going to use the answer key for that because that's where I've just stored it or just entered it into the answer variable. And then I need to tell it the matrix I am the row number that I'm multiplying, which I'm multiplying row 1. That's where the leading one was. and I'm going to add that to row 2. And then I'm also going to add on, not that I need it here, but in general, just as a reminder, I do the convert to fraction key. I won't need it in this case. There's not going to be any fractions, but if there are, you always want to do that. Right? And so that gets me my 0 right there. Now I want to get a 0 here, and how do I do that? I'm going to do just edit second entry and edit. I'm going to do my multiplier is now -2. Answer, right? This matrix here, I want to operate on that. And I'm going to multiply row 1 by -2, but I'm going to add it to row 3. Change that 2 to a 3. And then we're ready to hit enter, and we get that 0 there. So I can write this out now. There I got my first column that I want. The rest, write down. Here's my dashed line. And then I'm keeping track of what's happening over here to the identity, because this will become, over here on the right-hand side, the inverse. Okay. Now what? I need a 1 right here. Hey, we're lucky. We got a 1 right there. So what do I do now? I'm going to get a 0 beneath it. All right, and how am I going to do that? I'm going to take row 3, and I'm going to add 3 times row 2, because that's where my pivot 1 is now. I'm going to add 3 times row 2 to it to get a 0 here, and replace row 3 with that. So second entry, I'm going to, my multiplier is 3. Again, answer, it's my previous matrix. And I'm multiplying this time row 2, and I'm adding that to row 3. And it gets my 0 underneath there. Okay. And then what? I want to get a 1 right here. How do I get a 1 right here? Well, let's simply multiply row 3 by -1. So second matrix math. This time I go down, I want just multiplying a row. And the syntax here is just the multiplier, which is -1, and the matrix, which is answer, and the row number, which is row 3. And I can convert to fractions, but I don't need it in this case. Okay. So now we get the following. +1. So all those change sign in the third row. Okay, so we're almost there. We got the 0. We got the, it's in row echelon form now, right? But we need to be reduced, which means every leading one needs zeros in it. So we need to get zeros everywhere else here. And so let's get these two guys to be 0. How do we do that? Our pivot 1 is here. So I'm going to take row 1, and I'm going to add -2 times row 3, and add that to row 1. So that will 0 that out. And then for row 2, to get rid of that 1, I'm going to add -1 times row 3. Do second entry to get back to my adding a multiple of one row to another. So my first one, my multiplier is -2. Insert -2. And I'm multiplying row 3. And I'm adding that to row 1 this time. And that will get my 0 above there. And then to get this 0, second entry, my multiplier is -1. Multiplying row 3, but this time adding to row 2. And there's my matrix almost there. Let's write this out. 0, 0, 2, 1, 0, 0, 0, 1. Okay. And then scroll over to get what's happened over here. Okay. And one last step, right? Need to get that 2 to become a 0, and my pivot 1 is now in the second row. So I'm going to take row 1 and I'm going to add -2 times row 2 and replace row 1 with that result. So my multiplier is -2, multiplying row 2 and adding that to row 1. So hopefully that will give me my 0 there. And now I have the identity matrix over here, which means the matrix A was indeed invertible, because here's the reduced row echelon form of the matrix A, and it's the identity, which means that A is invertible. But I go ahead and copy down all this stuff. Okay. And so I'm stopped on the algorithm, but now what's the answer? What is the inverse of the matrix? So this tells me that A inverse is what? Just this portion in here. So here's the inverse. Okay. There's the answer, if you will. Of course, showing the support is important, which is back to row reduction, showing the individual row operations you're doing, and one step at a time converting that, right, showing that algorithm. But there's the inverse now. Now here's as a check, how do we know, can we make a mistake in here? Sure. But if you take this matrix and multiply it by the original matrix A, you should get the identity matrix. That's one way you can do it. So I could enter that in. Another way is the calculator has the inverse key here. So I mean, you have calculator, you can check your work that way. So I'm going to go back to the original matrix now. Remember, A was my original matrix. But I'm going to have to edit it because I want the inverse of A, 3 by 6 matrix. I don't want the inverse. I'm not looking for the inverse of this. In fact, there is no inverse of this because it's not squared. I just want the inverse of that, right? So all you have to do is go in here now after you've done everything, and you can edit that to 3 by 3. And when I do that, it just cuts off everything. Everything here is the same as the original matrix. And so now if I quit and go to second matrix and do matrix A with the inverse key right there, right below matrix, and hit enter, and there's my inverse. Is it indeed the same? Yeah. Okay. So again, getting there, finding that's important. Again, we're not button pushers, right? I mean, the calculator gets us that, right? But how is the calculator doing that? Okay. So I'm not exactly sure, but certainly this is a way that we can find the inverse of a 3 by 3 or larger matrix now, and a 2 by 2 as well, even though we have that formula we presented before. So this is the inversion algorithm, and you want to practice that with the homework.